Hi, welcome to my new video. Today I'm gonna talk about PySpark and serializers. So it could be a very simple topic because in general a serializer can be thought as a manner to exchange the data and to transform it and save into another format. But in fact in PySpark there are multiple serializers that are available, and depending on the use case and the code you write, PySpark will trigger the usage of different ones. So let me show you these few serializers in the code, and if you want to discover more, as usual there is a link to the blog post in the description of this video. So in my first demo, maybe just the first thing first, so as usual to debug a PySpark application I am adding some dummy prints. So here you can see the print that I'm going to call when my code will analyze arrow stream pandas UDF serializer, and I have done that for pretty much other serializers in PySpark. So the first category of serializers belong to the Apache Arrow serializers, and you will use them very often when you have some pandas data frame that you want to consume or use in a PySpark application with a PySpark API. You will also have Arrow Stream Serializer, Arrow Stream Pandas Serializer, and Arrow Stream Pandas UDF Serializer that respectively also let you use pandas with PySpark, but here mostly for the computation. So here you can see that I have a pandas UDF, and finally the last one is Arrow Stream UDF Serializer, and here also I have some user-defined function working on top of the data generating by Arrow batches. So let me just run one of them to show you the serializers that I used. So as you can see, PySpark used here Arrow Stream UDF Serializer, Arrow Stream Serializer to dump and load the stream and exchange it with the Apache Spark JVM backend. So that was the first category. The second one comes more from the classical RDD processing that were historically available on Apache Spark. And the first specific serializer to this family is the CartesianDeserializer. And what can we find here in the output? So we can find something called CartesianDeserializer that, as you can see, is used to handle this Cartesian call and create batched serializer streams. Another specific to serializer to RDD is the FlattenedValuesSerializer. So in fact it's not specifically related to RDD, more is related to the shuffle that is made also on PySpark case. That's something I also discovered during this learning or serializers learning. And spoiler alert, I will blog about the shuffle in PySpark, purely in PySpark, in 1 or 2 weeks, if I'm not mistaken. But anyway, let's see what happens here. So I have a mapping function generating some pairs, and later group by key with map values method, and consuming it, the transformation with for each partition. And you can see that we are doing some spilling on disk with the help of FlattenedValuesSerializer. You can even see it better in this log message. We are using FlattenedValuesSerializers that, of course, as many other things in Spark, but also in these serializers, can reference other underlaid and more specialized serializers or more generic ones. In the case of FlattenedValuesSerializer in spilling, we are going to serialize the data by batches that are whose size is resolved automatically, and we will save them in compressed format on disk. So as you can see here, it's another use case of serializers in PySpark. FlattenedValuesSerializer is not here for exchanging the data with Apache Spark JVM backend, but instead FlattenedValuesSerializer is used by PySpark to create shuffle files on disk, so completely decorrelated from Apache Spark JVM backend. Because, as I said before, you will discover that shuffle also exists purely in PySpark in one of the following articles. And there are two remaining serializers. The first one is the MarshalSerializer. It's one of the historical one in PySpark, supposed to be more performant than the default PickleSerializer available right now by default, but supporting less types. So yeah, you must advise, you must to make some trade-offs in this while trying to use this serializer. And I'm taking advantage of this MarshalSerializer demo to show you that we can also override this default serializer that in PySpark is called PickleSerializer by specifying a serializer parameter in Spark context. So as usual, I will run the code, and you can see also it uses the old RDD API, so not old but low-level RDD API. And you can also see in the prints, in the logs, that we are currently dumping and loading data with MarshalSerializer. And the final ones here are UTF-8 and PySpark meaning that Spark will use them to, at least in the case of UTF-Deserializer, to convert instructions and other strings received from the Apache Spark JVM backend and adapting them to PySpark execution context. And when it comes to the data, this UTF-Deserializer will be used for everything touching text. So for example, here the RDD text files, and you will see that in just a minute. So there are plenty on initialization, and maybe if I add an extra log, we can see maybe this method. As you can see that it's used, so maybe we can also print what text is loaded with this serializer. So this is on the, yeah, because you can see on status and the name of the file and also the content of the file. And before I finish this demo, I have one last thing to share. So in each application, in each serializer demo, you certainly saw this newer serializer print. Where does it come from? It comes from the serializers package and the default CloudPickleSerializer that, depending on Python version you are using, will be different. So for version lower than 3.8, Spark will use PickleSerializer, whereas for the newer versions, it will, starting from 3.8 of course, it will use CloudPickleSerializer, which has better support for the types unsupported so far by this default PickleSerializer. So that's pretty much all. You can see that these serializers are pretty well hidden in PySpark code, so that you as a high-level user don't need to worry about them, don't need to worry about configure and fine-tune parameterize these serializers. But yeah, it's better to know that they exist, because sometimes you might encounter some serialization issues. You may maybe want to try to find some parameters that you can fine-tune, for example, for Arrow serializers, in order to adapt them better to your specific workload. So it's generally a good thing to know, and not to mention that this serializers demo and article from the description of this video learned me also something extra about this PySpark on the Python side, Python virtual machine side, and Apache Spark on the JVM side communication, which becomes more and more clear with every new blog post. And as I said before, another surprise that I discovered here was the shuffle in pure PySpark code on pure Python PySpark JVM, Python PySpark VM part, And it's another topic that I will cover later in this release batch before the Christmas break. And so to sum up, as usual, please check out the blog post from the description of this video. You can also subscribe to the channel or subscribe to the newsletter, which is available on the blog post, so that you don't miss any new articles. It was Bartosz Konieczny from waitingforcode.com. Thanks for watching.